All right, folks, here we are on page 105. We're looking at number 4, part A. We've got 8 women and 5 men standing in a line. How many place arrangements could there be for any position? Well, all we got to do here is we got 13 people altogether, and 13 factorial will tell me all the different arrangements. Now, for part B, they want to know how many arrangements will if all 5 men are standing next to each other or together. So the men are all together. They're one group. All right. And then we got our 8 women. So what we're going to do is count the men as one thing. So that gives us a total of 9 things that we're rearranging. So that's going to be 9 factorial. But the thing is, the 5 men, they can stand in different positions. So that means that we have to multiply that times 5 factorial for the different ways they can be arranged. And then you get that together and you get this. Now in part C, they want to know how many arrangements where no 2 men are standing next to each other. All right, so here visualize all the women and all the spots that they could have. We got 8 women, and the men have to stand between them or outside them. So the first thing is to figure out how many different ways the women can stand. Well, the women can stand 8 factorial. We arrange them. Now, as far as spots for men to stand, we can look at them here. That's where the stars are. And there are going to be 9 different spots. Now, what we've got to do is figure out, how we're going to give them up. Well, we've got 9 spots. We're going to go 9 for the first spot. We have 9 choices. And then we've got 8 for the second spot. That's 9 for the first spot, 8 for the second, 7 for the third, 6 for the fourth, and then 5 for the fifth, giving us this total. Now, the other way you could do this is that you could do 9p5 as a permutation, because that is the same thing as 9 times 8 times 7 times 6. All right? So now let's take a look at number 5. In number 5, we've got these numbers here, 1, 1, 2, 3, 3, 4, 6. And they're all written on separate cards, and then we're going to rearrange them, and we're going to use all of them. So A, it wants to know how many distinct 7-digit numbers there are. So first, we're going to take the number of numbers. There's 7 of them. And then we have to look to how many repeat. Well, there's 2 1s and there's 2 3s. So 7 factorial divided by 2 times 2 factorial times 2 factorial. And that gives us 1,260. Now, for part B, they want to know how many of these are even. Well, for it to be even, the numbers have to end with a 2 or a 4 or a 6. So all we got to do is look at those different scenarios. If it ends with a 2, well, that means that there are going to be 6 other numbers, and 2 of them repeat. So 6 factorial divided by 2 factorial times 2 factorial, and that's going to give us 180. Now, if we look at the even numbers where there's a 4 at the end, again, there'll be 6 numbers left over, and again, 2 of them repeat. And if you put the 2 at the end, it's also going to be the same, because you'll notice the even numbers don't repeat, so they're not going to change. You add all those up, you get 540. Now for C, divisible by 4. Well, you have to look this up, but if a number is divisible by 4, the last 2 digits are divisible by 4. So again, we just kind of have to lay that out. If you look at it, we can first say, okay, if I put a 2 on the end, what number can I put beside it to make it divisible by 4? Well, a 12 would be divisible by 4. I can do that. And if I had 2 on the end, I could put a 3 next to it. And that would give me 32, which is also divisible by 4. And that's one of my numbers. And that's all I can think of ending with a 2. So then if I figure it out, well, there's 5 numbers left over, and 2 of them repeat. So 5 factorial divided by 2 factorial, and it's going to happen twice, both for 1, 2, and 3, 2. So that's going to give me 60 plus 60, or 120. Then I pick the next even number, say 4, and if I put 2 in front of it, that's going to give me 24. And if I put a 6 in front of it, 64, both divisible by 4. So then if I figure out the number of ways those can be arranged, well, again, 5 factorial, but now 2 of the numbers repeat, both the 1s and the 3s. And so I got to figure that out. That's going to be 30, but it's going to happen twice, so that'll be 60 altogether. And then if I pick the last digit being 6, well, I could have a 16 or a 36. And again, there's 5 digits left over, and then 2 of them repeat in both situations. So then I end up with a grand total of 300 ways. Now, part D, how many of these 7-digit numbers end with the same digit? Well, we've only got 2 numbers that repeat. We've got 2 1s and 2 3s. So one of the numbers must have started with 1s and ended with 1s, and the other ones must have started with 3s and ended with 3s. All right, so all we have to do is figure those out. So if I put 1s on each end, that's going to give me 5 in the middle. And out of those 5, 2 of them repeat. So that's going to be 5 factorial divided by 2 factorial. And then if I put 3s on the ends, well, again, I still have 5 in the middle. And 2 of them still repeat. So that's also going to be 5 factorial divided by 2 factorial. And so that's going to be 60 plus 60, or 120. All right, hope that helped. Thanks for watching.